This program contains experiments which are performed by professionals. These tests are dangerous and may involve the use of hazardous materials. They should not be performed or imitated under any circumstances. It's all about light. The digital camera. It's revolutionized photography by transforming light into electricity. Everything is there to draw in light, from the camera's buttons, controls, and dials down to the lenses. What the digital camera does with light is what makes it so revolutionary. It turns light into electrical charges that become the image captured on the screen. Light particles, or photons, leave the source, bounce off a subject, and enter the camera through a series of lenses. The photons then follow a designated path on their way from photon to photo. A series of lenses allows the photographer to capture the clearest image possible. This lens diaphragm is what controls the amount of light that the photographer allows in through the camera's opening or aperture. After crossing the diaphragm, the lenses, and entering the aperture, the light bounces off a mirror and heads for the viewfinder. Before it gets there, the light is flipped over as it passes through a prism. That's so the image seen in the viewfinder is right side up. If the photographer likes the image, time to press the shutter button. The mirror lifts and the light rushes in. For a fraction of a second, the light is not heading in the direction of the viewfinder, but for the very heart of the digital camera, the image sensor. The duration of this fraction of a second depends on the shutter. That opens just long enough to expose the sensor to light. Now, to the real heart of this digital revolution, the element that captures the image, the image sensor. A tightly structured grid made up of extremely tiny light sensors. When the photons hit the light sensor, they are absorbed by the semiconductor material it's made of. For each photon absorbed, the light sensor emits an electric particle called an electron. The photon's energy transfers to the electron. That's the electrical charge. The brighter the image, the stronger the electrical charge is. So each electrical charge has a different intensity. A circuit board then converts the different intensities into computer language. They represent millions of tiny colored dots that make up a photo. The pixels. The more pixels in a picture, the better the resolution.